a short, approximately 3-minute video on optical limiting and Z-scan produced by the Nonlinear Optics Group at the Center for Research and Education in Optics and Lasers, CREO, at the University of Central Florida. What we're showing here is the frequency doubled output of a nanosecond neodymium YAG laser focused into a cell filled with acetone where we've dissolved some organic molecules into it. We'll call it modified acetone. What we'll first show is an optical limiting experiment. Here we're slowly increasing the input energy focused into that cell, which is sitting at a fixed position, and we're looking at the target at the beam. And as you'll see, as the input energy is increased gradually, you'll start to see there the beam spreading out due to the nonlinear interaction in the acetone. And you'll start seeing rings forming, and thus the energy per unit area is being spread out, and this is the optical limiting effect. And what we'll do next is we'll do the Z-scan, where we fix the input energy and we'll be moving the cell. Now, the first thing you see is we're getting near the peak. You'll see the beam start to compress on the target. There you'll see it slow, see it getting smaller. That's the peak of the Z-scan signal. And then as we move toward the valley, you'll see the beam spread. And you'll actually see the beam spread to the point where it almost will disappear, and that will be the minimum of the Z-scan. It's important to remember here, the input energy is fixed. There you see it slowly disappearing. And then as you get on the other side, the sample, by the way, is moving away from the lens. You can hardly see it move because the depth of focus is small. And now we're getting back toward the linear regime where the beam is, there's no nonlinear interaction in the sample since the irradiance is low. Now next what we'll show is a Z-scan with a fixed power helium neon laser, several milliwatts. And this is a similar solution of organic molecules in a liquid, and we'll move the sample, and again we'll go through the peak first and then the valley. And now you see that the light gets looks like it's slightly focused on the target, and that's the peak of the Z-scan. And as we move the cell farther away, this is strictly a thermal defocusing nonlinearity. As we move the sample farther away, we'll go through the valley where the beam gets significantly spread. You'll see the beam gets very dim here because it's spread over a large area on the target. And then we slowly, as we go past the minimum toward the linear regime again, the beam comes back to a collimated helium neon beam. And so it's a very nice and simple experiment that most anyone can do in a laboratory by simply mixing a slightly absorbing dye or organic molecule in acetone.